Good morning. Welcome to the first lesson in Unit 3. This is actually a very short unit, and it will mostly be material from Algebra 1, so we will move through it fairly quickly. This unit is on systems of equations, and we're going to talk about the different ways that we can solve systems of equations, but before we get to that, I think it's really important to establish what a system of equations is and what we're finding when we're finding the solution to a system. Because it doesn't do us much good to memorize a bunch of steps for coming up with an answer if we don't understand what that answer is and represents and why those steps actually work. So the first question that I have on the slide here is, what is a system of equations? A system of equations is two or more, okay, so you can have more than two equations, equations that have the same variables in them. So two or more equations with the same variables. And I will flip over to the next slide and I'll give you a couple examples of what systems of equations look like. So here's our first example. We could have something like 2x minus 3y equals 4 and 4x plus 2y equals 1. And this would be what we'd call a 2 by 2 system, meaning we have two equations and we have two variables, the x and the y. And we're looking, well, we'll get into what we're looking for. So that would be what's called a 2 by 2 system. Here's another example. We have 3x plus 2y minus z equals 3. X plus y equals z, and negative 1, I don't know why I put the 1 there, that doesn't hurt, negative 1x plus 4y minus 3z equals 0. This is what would be called a 3 by 3 system, meaning 3 equations and 3 unknowns or 3 variables. So we have the x, the y, and the z. Not all systems of equations have to be linear equations, so you can have a system of equations that might have a quadratic equation combined with a linear equation and so forth. But the bottom line is a system of equations is two or more equations that share a common set of variables. So when you're looking at problems, if we're talking about systems problems, that's what we're talking about. We're talking about solving more than one equation at the same time. There's another name for systems of equations that's a little bit older, and that is simultaneous. There we go. Simultaneous equations. That's a little bit older term. I think like my mom would use the term simultaneous equations. I use them both. Most people now use them both. But the idea of simultaneous would be the idea of you have more than one equation and you solve them at the same time. So you go through a series of steps and processes and you're finding your solution. If you have a TI-85 graphing calculator, it will do systems for you, but it'll be under the heading simultaneous. So you would need to know that vocabulary to access that on your graphing calculator. So now that we know what a system is, it's a group of equations that share the same variables. When we're asked to solve them, what are we being asked to get? Again, that vocabulary of solve this system, it doesn't mean anything if we don't know what we're aiming for. So what is the solution to a system of equations? A solution is the values of the variables. So remember, we're dealing with equations that share the same variables. The values of the variables that make all the equations in that system true. And if you're not in the habit of taking notes, you should write this down, or if we're doing it on a PowerPoint, underline it, because that definition is important, because that's how you know what you're aiming for and how you know when you've arrived. You're looking for the values of the variables that make all the equations true. So in this system here, I am looking for a value for x and a value for y, that when I plug them into the top equation, I will get a true statement. And if I take that same x and same y values and I plug them into the bottom equation, I will get a true statement. So it's like a value for x, a value for y that work for both. Here it would be a value for x, a value for y, and a value for z. And you could plug them into the first, the second, and the third, and all of them would give you a true statement. Now, why that's important is because, again, lots of the tests that you guys take are multiple choice, which means that you would be shown a system and then you would be given 4 or 5 options for solutions. If you understand that definition, you can basically plug and check the answers because you know what you're looking for. What should the solution do? It should make all of the equations true. If you plug the answer choice into the first equation and it's false, then you don't even have to plug it into the second one. If it works for the first, you check it for the second because it has to work for all of them. Now, there are 4 main strategies for solving a system of equations. So let's get that up there. So 4 main strategies. 3 of these you will be familiar with, and one of them you probably won't be unless you happen to have studied it in one of your previous math classes, but it would have been something extra that the teacher probably did. The first strategy that is usually covered is graphing. And this has some pros to it. The concept behind the solution of a system being done with a graph is very, very important. But the drawback with graphing is that the graph has to be perfect. It has to be perfectly graphed. So if you're doing a line and your line like wavers a little bit or it's got a little bit of a bend to it, which most of ours do when we're graphing by hand, then you won't get the right solution. Now, a calculator will solve that problem. And so generally speaking, after about Algebra 1, if you're going to do the graphing method, you're going to do it on a graphing calculator, which will solve the accuracy problem. And it's actually very, very powerful. You can solve any kind of equation that way as well. The next strategy that's often taught is the substitution method, which is the title of this lesson. So we will be going through the substitution method. That's my personal favorite is the substitution. And it's because I think when I was in school, the substitution method is the one that made the most sense to me. I understood why it worked. And so because I understood why it worked, I didn't have problems figuring out how to solve problems that way because it made sense to me. Where the other strategies, I could do them, but they didn't make as much sense, and so I never felt quite as confident. Now I feel confident with all of these strategies. The third one is what's called the elimination strategy, and this is the favorite of most people. Most students that I teach prefer the elimination method. It's more versatile than substitution. That means it works better for a wider variety of problems once you learn how to get the hang of it. The drawback to the elimination strategy is that you do have to think to do it. It's not just a bunch of steps that you can follow and you'll get to the answer. You have to stop at different points in the problem and make decisions about how you want to proceed, and then you have to figure some stuff out. And the fourth strategy is using what's called determinants. And that is a form of matrix, and it's a really cool way to solve problems. And if you have a calculator, you can solve really complicated problems with determinants, but this is not in this course. So one year, I did teach determinants, something called Kramer's Rule, to my Algebra 2 kids. And I did it like the day before we went on the holiday break in December because I knew attendance would be low and I needed like something to teach that day. And so I showed my students how to solve systems with determinants. It's kind of a cool lesson. I do cover it with my dual enrollment kids, how to solve systems that way. Now, a fifth way, which I guess I won't, I'll put like a little line here. Is to use your calculator straight up, calculator, there we go. And this would be the Casio model, the Casio graphing calculators, as well as some Casio Scientific. So I have that awesome Casio Scientific that I've used in class a couple of times, are actually programmed to solve systems of equations for you. So you just like plug in the numbers and hit enter and it will dump the solution out for you. It's awesome. So if you have a Casio calculator, I would strongly encourage you to learn how to use that feature with it. So we are going to cover in this class, we're going to cover substitution, elimination, and we'll touch on the graphing, but again, after Algebra 1, it's pretty much, you're going to use a graphing calculator if that's how you're going to do it, but we will touch each of those. So let's talk a little bit about the substitution method. So I mentioned this was my favorite strategy when I was in school because conceptually it just made sense to me. But we really need to address the question, when should I use this strategy? Because it actually doesn't work well all the time. You should use this strategy when one of your equations, one equation is solved for one variable. And that's important. So take a moment, write that down, take a picture of it. When should I use this? When one equation is solved for one variable. Let's go back and make sure we know what the vocab means. Solved for means get by itself. So if you are asked to solve for R, solve for H, or for Y, it means get that by itself. So it means that one of your equations would look like X equals or Y equals. And too many students think that it has to be the Y. It doesn't have to be the Y. It could be the X. Now, you can also use substitution if it's easy to solve one of the equations for one of the variables. So even if it's not already solved, if you can do the solving in one step, then substitution would be a good strategy to use. So we're going to look at 3 examples. And I'll take you through that, and then we'll call it a day on the first lesson on substitution. So here's our first example. It is 4x plus 2y equals 7 as one of my equations, and the other equation is y equals 5x. And so I know I know it's a system because I have 2 equations and I have 2 variables and I have the same 2 variables in each equation. And I know that substitution is a good strategy to use here because one of my equations is solved for one of the variables, namely the second equation is solved for y. So that's just a tip off that this is a good strategy to use. Now I'm not going to outline the steps. I'm just going to show you the steps and explain them as I do. So the idea here is that when you substitute, you replace something with something else of equal value. Let's talk a little bit about what the word substitute means. So I said this out loud a moment ago. To substitute means to replace one thing with something else of equal value. But it's not, you don't replace something with the same thing. It's got to be different in some significant way. So I'm going to give you a couple of examples totally outside of math class of substitutions. If you have somebody in your family that's diabetic, you will often make cooking substitutions. And so in like a pie recipe, my dad is diabetic and my mom makes a pumpkin pie. And one of the substitutions she can make is she can take out the sugar and she can replace it with Splenda or stevia or some other sugar substitute. Now we can debate like whether or not that's better or healthier or whatever, but the idea is she takes out the sugar and she puts in something else of equal value. And in this case, it would be equal sweetness in order to provide that same function in the pumpkin pie. But it's different in a significant way in that it won't make my dad's blood sugar go up. Another example might be in sports where you might take out one pitcher, like in a baseball game, and replace it with a different pitcher, like a totally different person. Now, they have to be equal in some way, of equal value. They both have to be pitchers. You don't usually replace a pitcher with a left fielder. In baseball, I mean, if you do, I don't even want to know what's happening in that baseball game that would happen. But you don't. You replace a pitcher with another pitcher. But that pitcher is going to be different in some significant way. Maybe that pitcher is a left-handed pitcher instead of a right-handed pitcher. Or the pitcher is just simply not tired. The pitcher that was in has gotten fatigued and tired, and you need to put in somebody with a fresh arm. So you can think of lots of examples outside of math class where you do substitutions. And remember, that idea is you take something out and you replace it with something of equal value but different in some significant way. So here's how the substitution works. I'm going to copy this, and I'm just going to highlight the y. Because this is already set up, this is a fairly straightforward substitution. So I'm going to take the second equation and substitute it into the first equation. I'm going to take out the y. So observe here, I have taken out the y. The y is missing. And I am going to replace the y with something of equal value. Well, what's equal to the y? 5x is equal to y. So there's the substitution. Work top to bottom, top to bottom, top to bottom. Some of you are getting comments on your homework every single day because you're not working top to bottom. Work top to bottom. It's going to hurt you if you keep not doing it. So I've taken out the y and I've put in the 5x. They are of equal value, which allows me to do it. But they're different, and I need to make sure I put a times sign right there because that was multiplication. What I just did there, it was 2 times y, so it has to be 2 times 5x, and I need to put the times sign, otherwise it becomes 25x, which is not the same thing. But they're different in a significant way, okay? So, and here's the significant way. This has an x in it instead of a y, which means now I have an equation with only one variable, and we know how to solve that. So 4x, 2 times 5 is 10, and I have like terms there, so I can add 4x plus 10x is 14x, divide both sides by 14, and I get x is equal to 7 over 14, but nobody wants that fraction, so let's simplify it to 1/2. And a lot of students will be like, oh good, I'm done with the problem, I found x. Now, we got to go back to what are we finding? Here we go. So what are we finding when we find the solutions? We're finding the values of the variables, plural. So all of the variables, we have to go and find a value for them. And right now, I only have a value for x. I have to go and find the value for y. Once I have a value for x, then I will take that value and plug it into either of the equations. It does not matter which one you plug it into, but plug it into whichever one looks easier, which in this case would be the second one. Our lives are complicated enough without us, making them harder by plugging stuff in that's harder. And so now we'll do another substitution. We know that x is 1/2, so I take out the x and I put in the 1/2, and then I can just multiply those across, and that's 5/2. Don't make your life harder by trying to change it to a mixed number. Just leave it. Now I've kind of run out of space on this. And it bugs me when you guys do this on your homework, but I have absolutely no space here. So I guess I'm going to write the solution up here. X is 1/2. And y is 5/2. I apologize. Do as I say, not as I do. When it comes to writing your answer, you can write it as an ordered pair, like the x, y, or you can just leave it as x is 1/2, y is 5/2. It kind of depends on the context of the problem. Here's our second problem. We have another 2x2 system. We're going to keep this to 2x2 linear systems in this class. Again, an honors section, they would make this much more tangly for you. You'd have to tangle with the 3x3s, and they do a lot of nonlinear systems. But we're focusing on that ground level concept. If you get the ground level concept, you'll be able to do the higher level problems. So we have here x equals 7 minus 3y and 2x minus 4y equals 24. Again, notice it's 2 equations that have the same variables, and the reason why substitution is a good strategy is because that top equation is solved for one of the variables, meaning we have the x by itself. And I like to use this example because so many students think it has to be the y because that's what it's done, like all the examples are done with y's. It doesn't have to be the y, any variable. So here's our substitution. We're going to take the first equation and substitute it into the second. And I'll do what I did last time. I'm going to highlight where that substitution is, just so you can see it a little bit better. So we're going to take out the x. Remember, substituting, you take out the sugar, you take out the original picture. And then we're going to put in place something of equal value. Well, what's equal value to x? 7 minus 3y. And everything else in that equation stays the same. So bring down the negative 4y, bring down the equals, bring down the 24. And what makes that different in a significant way is that now I have an equation that just has y's in it, and I am able to solve for the y and get a value for y. So let's go ahead. 2 times 7 is 14. 2 times negative 3y is negative 6y. Combine your like terms. So negative 6 minus 4y. Remember, these are both negatives. Miss Taylor's Algebra 1 teacher. Plus negative 6y plus negative 4y would be plus negative 10y. We are subtracting 14 from both sides. Yeah, I guess we'll come up here. And again, you're subtracting 14 because 14 minus 14 is 0. You're not adding it because of the negative here. That negative is still there. So we end up with negative 10y equals 24 minus 14 is 10. Divide both sides by negative 10. And we get y is equal to negative 1. And again, I'm only halfway done because the definition of a solution is the values of the variables that make all the equations true. And I only have one variable here. So I take my value for this variable, y equals negative 1, and I can plug it into either of those original two equations. But make life easy on yourself. The top equation looks way easier. So I have x equals 7 minus 3. And again, I'm highlighting this. I know it takes a little bit of extra time, but I think the visual is valuable there. I take out the y, and I'm going to put in the negative 1. And then watch your order of operations. Multiplication is before subtraction. So we do negative 3 times negative 1, which gives me positive 3. And then 7 plus 3 is 10. And there's my answer. And you can write it as an ordered pair. So you could write it as the point 10, negative 1 is also acceptable. If you don't have x's and y's and you're going to write it as an ordered pair, the recommendation is that you go in alphabetical order. So if you happen to have, like the next example I have has an R and a T in it. And so you would actually do that with the element of PQRST. Okay, so you put the R first and then the T. All right, I'm going to call it on this lesson. I know if you've got the printed copy of the notes, you know that there are actually a couple more examples, but I like to keep the lessons to about 20 to 25 minutes, and so we're about there now. What I'd like you to do is to make sure you go back and understand the concepts that we covered in this lesson. So it's important that you know what a system is, so that you know when you're looking at a system, what the solution is, so you know what you're trying to find and how you know if you found it. And then know that we are covering substitution, and we will pick up with elimination in a couple of classes.